Okay, this is lesson 2.7, day 2, and today we're going to prove angle pair relationships. In the previous lesson, you were learning a lot about vertical angles, linear angles, and just the theorems behind them. And today we're just going to apply it all into proofs. So we're going to do a couple proofs together, and then I think for homework you got a few more to do. So just again, proofs are very hard. I get that. You need to keep plugging away at it though, and keep trying something. Especially when you have that theorem card to look at, you should be looking at it, trying to at least narrow it down to a couple of options that you think the answer might be. So the very first one is always your given. So angle 2 equals the measure of angle 3, and that's our given. And once I get information like that, I'm going to go up to the picture and mark that so I don't forget that they're congruent to each other. And I kind of offset them a little bit so I can tell that there's two different marks there. So I know that they're equal. Eventually, I need to talk about 3 and 6. So way down there, I need to talk about that one. It might be easier for me to compare 2 and 6 and somehow tie this angle to the one I'm aiming for. So I'm going to talk about 2 and 6 because looking at them, I know that they are equal because they make vertical angles. Remember that vertical angles are just when two lines cross and then kind of the diagonals of each other, or the ones that point at each other. So 2 and 6 are vertical angles to each other. So I'm going to use vertical angle theorem. This is my symbol for angle, so I kind of abbreviated there. And now that this angle, 3, which is what we're aiming for, is equal to angle 6, this is how. So I have angle 3 equaling 2. I have 6 equaling 2. So anytime I've kind of got some overlap, I want to talk about how to just get that out of there or take out the overlap. Kind of like we were doing when we were doing lost syllogism. We would say, like, if I win the game, then we're going to state. If we go to state, we get a trophy. And so I can kind of cut out all the stuff about going to state and just say, if we win, we're going to get that trophy. And this, you can do the same thing. So I'm going to cut out the overlap, and I'm just going to be able to say that 3 and 6 are equal, and that's either the transitive, or you can use substitution property. Either one. Tuition. Next proof. This one has given measure of angle 2 equals angle 3. And that should say congruent. Nope, that's equal. And again, I'm going to mark, they already marked them for me. 2 is equal to 3. And I also know that AXD, here's AXD, it's this whole thing right there, that whole angle, is equal to the measure of AXC. AXC, so it's this whole thing. So that angle is equal to this one up here. So I kind of like to do that so I get a feel for how big of angles I'm talking about. Especially when there's a lot of letters and numbers being thrown around, it might be easier if I kind of have a visual about where they are. And that's always given, so that's nice and easy. The next statement they have is that AXD, the one that we were just talking about, is made up of 1 plus 2. So anytime you take two smaller pieces and add them up to be the whole thing, that's called some type of addition. And this is angles. So this is going to be angle addition postulate. If it was segments and we were adding up two bits of segments and equaling a whole thing, then that would be segment addition. But since we're in angles, we want it to be angle addition. Anytime you have two pieces and you add them up to be the whole thing. So they give me another reason as angle addition. So they must want me to talk about another angle that's made up of pieces. And since we kind of identified this other big one, although I could talk about, this entire thing, or I could talk about this angle in here, we already identified this as an angle that we are talking about, so I kind of want to focus on that one. I'm going to make it look like this one too, so I'm going to put the numbers first. So I'm going to say 3 and 4 are going to equal AXC. So this way I'm talking about both AXD and AXC. I just did them both right there. Angle addition postulate. If I know those two are equal, these two big ones, I can kind of get them to be equal to each other. Same property as up here. If I'm overlapping something or if we're both equal to the same thing, then we're equal to each other. And since both of these guys are equal to each other, and he equals that, and he equals that, I'm going to put all this stuff right there. I'm going to put all this stuff right there. So I'm going to make a big equation where I'm going to go 1 plus 2 equals, and then 3 plus 4. So anytime you kind of create equations, eventually you're going to be either setting them equal to each other or substituting something so you can do some algebra with them. And that's the substitution property. Could also be transitive. If you had to fill this part in, could also be transitive. Then when I get another equation that looks a lot like it, two things on each side, I kind of try and figure out what changed. So angle 1 stayed the same, angle 3, angle 4. This is the only thing that changed. So how can I change from angle 2 to angle 3? And up here I know that they're equal. So if angle 2 and angle 3 are the exact same thing, I should be able to take out one of them and put something else in. That's called substitution. This is one time that transitive won't work because you're actually talking about taking something out and putting something else in for it. So that is a substitution property. I know what I'm supposed to end up with. I'm supposed to end up with 1 equals 4. So I'm going to write that. And then I'm just kind of looking from step 5 to 6. What changed? So here I've got my 1. Here I've got my 4. And it looks like I got rid of the angle 3 on both sides. And I did that by subtracting it from both sides. So if I minused it on both sides, it would just go away. So subtraction property. Again, they are not easy. I know that. But you got to keep plugging away. You got to keep trying something and keep looking at that that theorem card and see if there's anything that you can possibly use. Next one, a little bit shorter, only 4 steps. I'm given that angle 1 equals angle 2. I'm going to mark that because I like to know that they're equal. Some kids will look at that picture right away, and because of how it looks, they'll put boxes in the corner. And I have to warn you that if it doesn't say they're 90s, you don't know that. Even if the picture looks like it, you can't say that they are. So make sure that you're only marking what you know. And right now we only know that they're equal to each other, so I just marked that they were the same. Second statement says that 1 is equal to 3 and 2 is equal to 4. So we're kind of combining 2 steps in one here. So 1 is equal to 3 and 2 is equal to 4. So what kind of angles are 1 and 3? They're called vertical. And vertical angles are equal, so I can say that they are equal to their counterpart by the vertical angle theorem. Number 3. This is where it gets a little tricky because we're going to do a little substitution. And there's a lot of things that are equal right now. We eventually need to talk about 3 and 4. So I need to do what it takes to get 3 and 4 into the same equation. Right now, one of them equals angle 1 and one of them equals angle 2. So what I need to do is swap one of these out so I get them both equal to the same thing. So what I'm going to do is take and swap out angle 1 for angle 2. I know they're equal, so I'm just going to take it out and put angle 2 in its place. That way now angle 3 equals 2, angle 4 equals 2, and so since they equal to both same thing, I can take that out and put them equal to each other. So I really have 2 substitutions, or I have 2 transitives, either way. This one, it works either way, because you're just dealing with 2 things that are equal, and kind of just taking out the overlap stuff they are equal to. 2 more proofs to go. The next one is talking about a bisector. We haven't done one of those yet, so here's something that's being bisected. And bisected means cut in half, so that's going to allow us to talk about 2 things being equal to each other. Since something is being bisected, it's being cut in half. So BD bisects AB, awesome. So we're going to say angle 1 equals angle 2, and that's because of definition of bisector. The bisector cut that angle in half, so as soon as it cut up the middle and cut it in half, then that means that's equal to that. So I can say that that is equal based on the bisector, okay? Then they talk about how ABC is equal to 1 and 2. And we've done that a couple times where we take 2 little pieces and we add it up to be the whole thing. So we know that's called angle addition postulate. Number 4. It's kind of blank right now. I'm trying to eventually get ABC, this angle, to talk about measure of angle 1. So what I kind of need to do is get rid of this angle 2. I know that 2 is equal to 1, so why don't we just substitute? So we're going to say ABC equals angle 1 and angle 1. And that's substitution. Here's another case where transitive won't work. Since you are taking this out and putting something in for it, that's substitution. The very last one, they took their 2 measure angle 1s and they put them together to make 2 of them. So all they did was simplify. 1 more left. This one has to do with segments. We haven't done a segment yet today. These have all been angles so far. So switch your thinking just a little bit and pay attention to your theorems. First one's always given, so AL equals SK. Given. I'm going to mark that so I know AL equals SK. Just those two little tick marks kind of help me remember that they're congruent. Then they talk about how AS, this, is equal to AL plus LS. And we kind of did the same thing up above where we were taking two pieces and adding it together to be the whole thing. And so this time it's called segment addition, not angle because we're not doing angles here. We're doing segments. So this is segment addition postulate. Then they talk about LK, which is this one, and they're saying that it's equal to LS plus SK, that and that. So same concept. I'm taking two pieces and adding it together to be the whole thing. So segment addition postulate. Next, I'm kind of looking, it looks like they kept things a lot the same here. I've got an LK, I've got an LS. So the only thing that changed was from SK to AL. And how can they do that? SK is equal to AL. So what they did was took it out and they put AL in its spot. That's called substitution. They took something out and put it in its place. So they took out SK, and since SK is equal to AL, they put the AL right there. Now LK equals LS plus AL. AS equals LS plus AL. So we've got an LS, we've got an AL. They are the same thing, which means these guys are the same. That's the last statement, and that can be substitution or transitive. For like the 8th time, proofs are really hard. They're difficult to get your mind around because there's no one way to do them. But you do need to keep looking at that theorem card, and I think you're going to start to notice the ones we continually use over and over again and which ones we don't see very often. So it should help you narrow down which direction your proof should go.